I'm going to try to explain the David Hamel's three-cone nested cone device, which is a rather bizarre contraption. But something like this, you got the three cones, and they're in this frame. And there's a magnet down here and a magnet up here. And so the idea is, and these are these are magnetically suspended so they can freely wobble. So you got this uniform magnetic field down the center, and these are aluminum cones. And so it's well known that aluminum atoms have a net spin, so they will, the nuclei have a net spin, so they will precess in a magnetic field. So this is a proton here, and it's got a magnetic moment and a spin. So in an external magnetic field, this will precess. It'll wobble like a top at its Larmor frequency, and that's a function of magnetic field strength. And then there's, depending on the atomic nuclei, there's different frequencies attributed to the magnetic field. So you got these the nuclei at these points here would be now precessing in this magnetic field going down the axis here. So as they're precessing, they're wobbling, and so because these cones are allowed to wobble and move a little bit, what I'm thinking is that this precessional energy, that all of these nuclei would align with each other and sort of lock in and synchronize with each other in their precession. So these two adjacent nuclei would lock in with each other and begin to synchronize their precession. So you get something like a coherent precession through the lattice of atoms in the aluminum here. And as they lock in like this, and you get this coherent synchronized precessing motion in the atoms, that shifting of mass, nuclear mass, might transfer to these the larger body of the cone at its resonant frequency. So this has a natural resonant frequency at which it will mechanically vibrate, and this process here might transfer energy at the resonant frequency of these cones, so that these cones would begin to vibrate at some resonant frequency that's synchronized with this process. And so when that happens, so now what's happening, we have an energy transducer here. So we have this, whatever process is going on here at the subatomic level with regards to the vacuum virtual processes that cause this nuclear spin, or cause the spin of nuclear particles. We don't really know. But there's some sort of an energy absorption transducing process going on here. So if this energy could be transferred to the mechanical energy to cause these cones to physically vibrate or wobble, that energy would be lost to the environment by moving the air molecules around. So when you look at refrigeration, when the refrigerant is compressed, the temperature of the refrigerant rises. This is in a gas state, by the way. So when it's compressed, the temperature rises, and then that temperature, or that heat transfer occurs to the environment. So energy is lost to the environment. And then when that refrigerant loses enough energy, it condenses into a liquid. And then when that liquid is then allowed to expand, it then absorbs energy from the environment, lowering the temperature. So in a similar process here, this could be what's happening. So what that would result in is possibly a reduction in mass, because mass is possibly attributable to the this energy here of the spin of the protons, and they're whatever's causing this precessional motion, this energy here, could be a property of mass on that level. And most likely it's quantized, like everything in the subatomic realm. And so when that energy is transferred to the environment out here, it's essentially siphoning it or transducing it from the local surrounding environment here. So there would be a reduction in and this kind of ties in. I see it tying into what Fred Alzafon was getting at in his theory about reducing the, quote, gravitational temperature, or the Earth's gravitational temperature in the surroundings, which would cause a mass reduction, a local gravitational reduction, as these virtual processes are absorbed and then transduced into the environment, into a different energy form, in this case mechanical energy, transferred to the surrounding air molecules and whatever. So, and then if you can kind of visualize intuitively, if you have a system of many of these gyroscopic particles, and they are now locked in with each other, processing at the same rate in a synchronous way, then as that energy is transferred to a larger structure, if you can imagine a vibrating system that at the right frequency, the larger system would absorb the vibration of these particles. So in a sense, it would calm them down, causing them to lower their precessional rate and polarize along an axis. And in this case, we have, because of the geometry of the cone, we have a converging polarization or converging axis. And then with the rotation of this charged particle, we have also, according to a couple different theories, we have these electrogravitational field lines coming in because the nucleus is positively charged and it's spinning. There's this movement going on here, and so a movement of charged particles is believed to cause these electrogravitational lines of force. And if you want to read more about this particular theory, I'll put a link in the description to a man named Nils Ragnerud, if I'm pronouncing that correctly. So if we got this conical shape made up of aluminum atoms, and so the net effect is it got these, because now all the spins are lined up along this axis here, so we have this converging field here. So what I'm seeing happening is now we have these, because if you look at the direction of alignment now, so the spins are now aligning in this direction. So the what I'm trying to show here in this drawing is, okay, so imagine the spin. Okay, this is the axis of spin here, and this is the direction of spin. So then the electrogravitational lines of force, I don't know if the direction is correct, it could be backwards, I don't know, but it's not important at this point. So the net effect would be, we have this alignment. Now because of the geometry, we now have all these electrogravitic lines of force, and here they would be like this. So you get the idea. So the net effect would be that along this axis everything cancels. So then the net effect would be... So I'm extending this theory a little bit of what I read on this website, electrogravityphysics.com, and I'm extending it a little bit to apply to the proton. He doesn't explicitly state that rotating proton or rotating nucleus would have this electrogravitic effect. That's just kind of my extension of it. But so in this structure here, in this conical structure, what I see happening is in this zone here, there's something of a depletion of vacuum energy density due to this interaction here. A depletion in this region here, and then on the outside we have more. If you're familiar with the Casimir effect or the Casimir pressure, which has been scientifically proven, where they have the two metal plates that are extremely close together here. So they're very, very small distance, a few nanometers apart. And so what they've observed is that there's this force that tends to press the plates together. And they believe that's because of the 0 point energy of the vacuum. Between the plates it would be calmer, and so there'd be less vacuum fluctuations in here than out here, so you'd have a difference in pressure. So that's a bit of a different concept than the lines of electrogravitic force. But regardless, whichever principle it is, it looks like the effect would be the same, in that there's a net, because of the geometry here, there's a net force developing on this side, which would cause a net force in this direction. So the result of these two processes, where this processional energy is transduced into mechanical energy and then lost to the environment, may cause a reduction in mass energy of the nucleus. So the overall effect would be that this would lose weight, and in this effect here we'd get a force developing, which would cause a lift or a thrust in this direction. So we get the two different processes, but the result is a loss in weight, or a loss in mass, or a loss in inertia. And then over here is a development of a force, a propulsive force, due to electrogravitic lines of force, kind of like what we would see in conical shaped capacitors charged to high voltages, T.T. Brown noted in his research, or this Casimir pressure acting on this kind of a geometry here. So if we apply this concept to this geometry, there would be theoretically a bit of a depletion in here, in this, like in here, the vacuum fluctuations in this zone here, resulting in a difference in pressure. A little bit like an airplane wing has a difference in pressure due to the geometry of the airfoil. The air moves faster over the top than the air moving on the bottom, and this difference in airspeed causes a difference in pressure, so you get lift, and that effect is lift, because faster moving fluids have a lower pressure due to Bernoulli's principle. One other thing I wanted to note about this theory about the electrogravitic force is the so in his theory, in Nils's theory, the gravity is caused by, so this is an electron moving in some direction at some velocity. This is as far as I understand it. So then the lines of electrogravitic force are normal to this vector here, to this velocity. So when you have an atom, here's your atom, and you got an electron zipping around, say on this plane here. So due to the motion of the electrons, there's a electrogravitic force due to the velocity, the combination of the velocity and the charge. So this, the motion of the electrons causes these. So it's a pseudo force of electromagnetism. That's what gravity is. And also with the converging lines of force, that's critical also. So whether it's electrogravitics or electrostatics, when you got the converging lines, so that's the lines are not, they're not parallel, but they're converging to a point. So this system here will, or a body or a mass in this system will experience a force, whereas in this system it will not experience a force, but this is due to the converging of the lines. Another theory for the operation of this device is that so due to the conical shape, the magnetic field, so the nuclei line up with this magnetic field, but they line up in a way that's, of course, converging. So when you got here's the nucleus and it's spinning, and it's a mass. So you got a spinning mass, you've got a gravitomagnetic field. So gravitomagnetic field. So when these, and it's parallel to the magnetic moment. So they're in the same direction. So this is gravitomagnetic and magnetic moment. So when these line up in the magnetic field, these atoms, you get and just due to the shape here, I guess you get an alignment of these two fields. So what this is here is a direct conversion of nuclear energy to mechanical energy, if it works, with no heat transfer, no heat involved. In fact, the whole thing might even get cold, and lose weight. Alright, so this is my simple setup here to test a weight or mass change in a rotating aluminum sample. It's actually a cone, and this is basically what it looks like. Probably neodymium magnets, neodymium and boron. So neodymium and boron have net integer, half integer nuclear spins, which according to this theory, or my theory, should produce some sort of a mass polarization when these materials are magnetized, and when they're rotated. Those two types of actions should cause nuclear polarization. To to some extent. So I tried to minimize vibration effects with this. I'm aware there is a bit of an error with that. So what I'm going to do is just show this thing just rotating, just the motor, just to show that this should stay 0, which it does. So what I'm going to do now is insert this into here. Which is a little bit tight because of tolerances and stuff, so just give me a sec here. Alright, easy peasy. Well, not really. The last one of these broke, so I had to reprint it, but anyways, here we go. I'm going to try and hold this steady just because there is some vibration there that tends to move it around a bit, and that will cause erroneous readings. Time for a new scale. So if I press too hard on it, in some spots it changes the reading, but it looks like it's pretty steady there. Now I'm not feeling much vibration at the base here, which is good. Let's say in minus 0.74. I've also been looking for movement on the plate here due to the vibration. So it's confusing, it's puzzling because it looks like an interesting result, but that's a bit of a nuisance, the vibration. So I'm just reversing the polarity here so the motor will spin the opposite direction. You get about the same reading there. I did have another battery hooked up, so I was trying to run it on 24 volts, but it was a little hard to dampen the vibration on that, so I'm just running it on 12 here. What I could do is flip this over and see what happens here with the readings, so I'll do that. And I can also remove some magnets here to make the field a little weaker, see what that changes. Okay, so I reversed this now, so the vertex of the cone is pointing upwards. So, I don't know, it looks like something's happening here. I would definitely want to redo this experiment with a better scale, a more robust, reliable one. Maybe with some kind of noise reducing something, vibration absorbing mat or something. I'm not sure yet. I have reversed the polarity of the magnets. it's a little hard to see on the screen, but it says minus 1.33 grams. Wow, that's impressive. Seems to be quite repeatable. All right, 2 more tests. One is no magnets, just the cone, and then one is just magnets. All right, so no magnets. Plug that in here. It's a bit of a pain in the butt to get these things in and out. All right, here we go. Oops. Vibration here on the table. It's moving the... I can feel it. Right now I can't feel it moving and I can't feel vibration. I mean, theoretically, rotating aluminum should polarize the aluminum nuclei to some extent, as that's been it's been scientifically proven by the nuclear Barnett effect, which is based off the Barnett effect, where polarization of spins happen by rotation. So I'm going to try the magnets. Okay, so it's just a stack of magnets here. I think five on each side. Okay. It's moving a little bit here. If you can't read that, it says minus 0.61. Minus 0.4551. And I'll flip it over. Oh, let's try that again. So that was a fairly stable test right there as far as this goes. Minus 0.66. Minus 0.74. Minus 0.6. Now this is a field probably of going through these magnets. These magnets are about right at the surface. They're about I think about a 1500 Gauss. So it's a pretty strong field going through there. Now whether this is to do with nuclear polarization or not, as far as the changing of weight, I'm not 100% confident to say that it is, just because of the nature of this, the vibrations and stuff. But yeah, worth some more. I'd say it's worth some more investigation. That's how it wants to move, this vibration. Kind of fun though. It's like my old videos.